And hello, welcome back to another video of Brain of a Penguin's YouTube channel. Anyways, in this video we will learn how to calculate slope. Make sure to have fun watching it, and see you in the video. So, what is slope and how do we calculate it? Stick around to find out. Regarding slope, as it is such a broad concept to learn, I have divided the learning into two parts. Today is part 2 and we will learn how to calculate slope. But first thing is first, if slope is a new concept to you, or you want slope taught to you in more depth, I suggest watching part 1, which not only goes over the basics, but some other slope mini lessons not explained in this video. Overall, I suggest watching part 1. First, we go over the basics of slope, a recapitulation of part 1, and that slope is a number comparing the steepness of a line. An example is that this line has a slope of 1. Between any 2 points, the x change, or horizontal change, or run, whichever one anyone prefers, is equivalent to the y change, or the vertical change or rise. Similarly, a slope of greater than 1 will have between 2 points an x change less than the y change. Do not worry about all of the inequalities for now. In due time, you will understand what I mean. To finish off this section of slope, the slope of this line will be less than 1, as between 2 points the x change is greater than the y change. The slope of this line would be negative 1, as between 2 points the x change is negative of the y change, or the y change is the x change multiplied by negative 1, or negative of the x change. For now, we may just look at this. You do not need to understand this fully, but just remember this at the end of the video. It will seem a whole lot more friendly to you then. Now on to finding slope, or finding the actual number of what slope is. It is really no more than one equation you can plug in, but I don't really care about this. If that is what you want, then go to an internet search. The reason I make my videos is to express a different kind of learning, one where there is more understanding rather than memorization. This equation I will show you is an idea of understanding to find slope, but not a mindless plug-in equation. Anyways, slope is found with the y change over the x change. This can also be understood as the y change between points of a line over the x change between points of a line. Some teachers will also show you this, which is the same thing. The triangle is the Greek letter for delta. In math, the delta is used to express the change of, or the difference in. Just thought you may be intrigued to know this. Anyway, now that we have the equation to find the slope of a line, let us find out how to use it. Here we have a line and 2 points, A and B. Let us say we are prompted to find the slope of this line. If you have watched part 1, I go over the definition of a line. For now though, understand that a line is infinite but also constant. Every point on the line will be proportional with each other. When finding slope, we need 2 things, the y change and the x change. Then we divide between them. But the real struggle is finding the y change and x change to begin. Because we have 2 points, let us find the y change going from A to B. Looking at the y values, I see a 6 for A and a 10 for B. Going from A to B, I now know there is a y change of 4, expressed like so. Next, we must find the x change. I see the x value for A is 5, and the x value for B is 12, expressed like so. We can find the x change of A to be 7. If you remember our equation from before, which is the y change over the x change, we can find the slope of this line to be 4 upon 7. This would be the slope going from A to B. You may be wondering why I always say from A to B. If you are not, don't worry, but the reason I do is because there is another way to find slope, and is by going from point B to A, shown here. Finding slope, we notice that the signs for both changes have swapped, but because a negative upon a negative results in a positive, both of these slopes are the same, even if found slightly differently. Here, we have another example and are prompted to find the slope, although this time we have a line, but there are no points. Finding the slope of this line uses the same process of the last example, but this time with one extra initial step. The step is finding 2 points to use, so we can find the slope between them. If we are given information like this and told to find 2 points of the line, we would really have to eyeball it. Usually, however, if you need to find points of a line, the points will generally be easy to spot. By easy to spot, I mean points that end up exactly at the intersection of the grid lines. For example, I can see one point aligning nicely at the y equals 5, right here, and another one at the y equals 10, right here. Note that I could have used other points in this process, but these are the first points I saw. Anyways, now we need to find the y change and the x change of these 2 points. Going from A to B, the y change descends from 8 to 5, making the y change of A to B -3. From A to B, the x change is from 5 going to 10, making the x change +5. Now that we have our y and x changes, we can finally find our slope, which going from A to B is -3/5. Note that slope is usually expressed as an improper fraction. Slope can also be expressed as a decimal, but is easier to have slope represented as an improper fraction. An improper fraction is easier to look at and easier to use when graphing. But I won't leave out going from B to A. The slope of going from point B to point A would use the same process as going from A to B, just a bit different. One can find the slope from both ways, not just one. It is important to have our perspectives broadened. Now on to finding the slope with points for a table giving us the coordinates of some points of a line. The process is really the same, just expressed in a less visual method. I can find the slope going back to our original equation, which is the y change over the x change. Let us find the slope going from points A to B. The y change would be a +6, and the x change would be -4. Simplified, the slope going from A to B would be -3/2. We can also find the slope in many different ways, not just going from A to B. For example, we can also find the slope going from B to A also to be the same, using the y change over the x change. In fact, with just these 3 points, there are 6 different ways to calculate slope for you probability people, all of which lead to the same slope we calculated at the beginning. For you visual learners, we can also plot the 3 points and find the slope from any of the points we see. On a side note, something to watch out for is a table like this when asked to find slope. At first glance, this may seem like a normal table of a line, so finding the slope would be the same as before, right? Wrong. This table is not actually the one of a line, and thus we cannot find a constant slope. We could have noticed this when seeing that the slopes are not only different between the points, but are also completely funkadilly when graphed. Anyways, I doubt you will see this very much with slope, if at all, just a sort of way to remind you that not everything can be as it seems. All in all, now let us move to the summary slide. After watching today's video, part 1-2 maybe, we know that slope is a number that describes the steepness of a line. Also, we can calculate slope by dividing the y change by the x change. This last one is more of a preference, but you will almost always find slope as an improper fraction. I talk about this briefly in the video, but do not worry too much about it. Anyways, that is it for this video. If you have an idea or concept you want explained in a future math video, comment down below, or my email is thepenguinbrain@gmail.com. Anyways, thank you for watching this video, and see you in the next video. And welcome back, Brain of the Penguin fans. Today, we are back with another World Edit question about slope. If you watched part 1, I asked you one question, but here I'm going to ask you a bit more complicated question. Anyways, here is the question using the World Edit copy and paste tool. What is the slope in estimation of this line? Oh my gosh, that was not supposed to happen. Bum, bum, bum.